How's it? Oh, there we go.
There we go.
Fantastic.
Okay. So welcome, Div 2 teachers. John, are you ready for this?
I'm ready. Let's skater scatter. We'll get at her.
Yeah, I wanted to do a shout out. I'll repost it in the chat that there will be COTOTs on October 7th. So those are the list of the COTOTs there, and I'll post that and the link. Okay, here we go.
Okay, so we have an hour, and it's a lot that I want to squeeze in an hour, so I won't waste a lot of time. Right now, you should have a handout. There's some cards, shakers, and dice. If you don't have all that ready to go, as long as you have some cards and you have some dice, that'll work really, really well. So let's get started. And we're going to be focusing in on multi-digit addition and subtraction with some multiplication fact fluency games. And my experience is that if kids have difficulty in these areas, it's often faces back that they don't fundamentally understand place value or the base 10 system. And one of the quickest things that we can do is to help the kids with that. And I'm just going to put in this one right here, and I'm going to go like this. I'm going to pause it. Okay. So what I have here is I have a video that I'm going to be putting on in just a second. And it basically is on the website, and it is the best with regards to helping convey the idea of place value and how it interacts with multi-digit operations. So here we go.
Videos, we've seen how to use solo cups for place value. We've seen how to use it for adding, and we've seen how to use it with adding with regrouping. What does it look like when we use them for subtraction? Well, here goes. We're going to have 6 tens for 60, 2 ones for 2. We're going to call that 62, and we record it like this. 6 tens for 60, 2 ones for 2. We're going to call that 62. And let's say, just for instance, that we're going to take away 29 of those. So let's start like this. First of all, let's do the ones. We're going to take 9 ones away from the 2. Well, I don't have enough ones to take my 9 ones away. So I'm going to borrow an extra 10. And so I'm going to borrow an extra 10. And I end up with now 12 ones. Well, let's go like this. 1, 2. And so when I take 12 ones and I take 9 ones away, I end up with 3 ones left over. I have 5 tens. I want to take 2 away, so I'll take those 2 totally away. And what I end up with is 3 tens. 5 tens minus 3 tens. Sorry, 5 tens minus 2 tens equals 3 tens. So 62, take away 29, gives me a final answer of 33. And to get all that,
So I'm just going to pause right now. A couple of key points in that particular video was when we didn't have enough ones, we decomposed one of the tens to give us 11 or 12 ones. And that 12 ones and those 5 tens still made 62. It's just composed differently. So that composing and decomposing of numbers is really important. And what I like about using red solo cups is every tens place, you can see the 10 was one place right in there. And in the base 10 system, we don't trade 10 ones for 10. We don't trade, we don't take away a 10 and trade it for 10 ones. What we do is we compose tens and we can decompose tens. And so that's why I like that particular video. Those are up on our website. And that's why I wanted to show you, because that has direct impact on some of the games that we're going to be playing later on today. So in your handouts, let me make sure I'm focused here correctly-ish. In your handout, these links, when you have it open on a computer, you can actually go directly to those things. And this kind of explains it. So let's talk a little bit about multiplication, because often that's an area that comes up. Actually, I'm going to skip this page for right now. I'm going to come back to multiplication. What I'm first going to do is I'm going to come up to page 7 up, add up. And that game basically comes from the resource called Math Shakers, Upper Elementary Shakers. And it's actually page 30 on that particular activity. So here's what I need you to do. If you have a shaker, open it up, go click, 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 grab it in the center. And just show me on the screen that you've got it like that. If you don't go through that management piece all the time, you'll know that you forgot to go through that management piece because dice will fly. Okay? And it just doesn't end well. So now that you've done that, here's what I would do with the kids. I would say, especially, in the afternoon, is what I want to do is I want to have the kids kind of get up and out of their seats a bit. So for what you're about to see, I'm going to apologize in advance because what is seen cannot be unseen. I might throw some music. Kids, we're going to do a quick 30-second shake dance, and it's going to look something like this.
Stay out too late. Got nothing in my way. That's what people say. That's what people say. I go.
I did apologize in advance, didn't I?
Nice
Because what I
move.
screen can't be unseen, because the couple people that had their screen on, I appreciate that. But what I appreciate even more is they didn't do this, like they were trying to poke their eyes out. So thank you for not doing that. So what I would do is I would go, yeah, I know. So what I would do is I'd go with my partner and I'd say, okay, well, I'm going to add all these up. Well, I see 6 and 6 is 12. 12 plus 2 is 14. 14 plus 1 is 15. And so now I've got that 15 plus 5 is 20, 23, 24. And so what I'm doing is I'm adding up my dice. I'm adding up my dice. 6 and 6 is 12, plus 2 is 14, plus the 1 was 15, plus the 5 was 20. And I was just using the associative property of addition to make it easier. So I tell kids, you don't have to add the numbers in order. No one's telling you have to add them in order. Add them up in the way that makes the most sense for you. Okay. And so that's what we do. And so then my partner, they would shake it. And while they're adding it up, I'm blinking and I'm thinking, well, would I add it up that way or would I add it up differently or whatever? Or I'm also checking for their accuracy. Well, here I have 6 plus 4 is 10. And this 4 plus this 1 makes 5. And that 5 plus that 5 makes another 10. So that's 20. And then 20 plus 5 is 25. And my friend says, are you crazy? I'm going to say, no, I was tested twice. And they would say, well, what you could do is you can go 4 and 4 is 10. Or sorry, is 8 plus 2 is 10. 6 and 5 is 11. 11 plus 10 is 21. Plus 4 is 25. So we're both are using the associative property. We're both choosing the easy numbers that are easy for us. And we're still going to come up with the same answer, even though we decided to add it up differently. When I look at student samples for this, as I knock over my speaker, we'll come back to that speaker later. Come on, Jenny. I find if I talk to myself, it works better. This is a grade 5 sample from a few years ago. And in this grade 5 sample, what it is the grade 5s were working with the grade 1s next door in the school next door. And they were going over on Friday afternoons and working with the kids on their math or their reading, whatever. And so the grade 5s were doing 7-Up Shake Up. And this was in March of that year. And by March of that year, grade 1s have things like counting on, counting back, doubles plus 1, 9 plus rules. So they have a lot of strategies to add multiple add-ins. And so the grade 1s would shake the dice. The grade 1s would add the dice. The grade 5 was there to check for accuracy and also to record. So over the course of that afternoon, they did 50 samples. Now, that's way below grade 5. But I guarantee you, a lot of my grade 5s needed that practice. And then what we did is when we got back to the classroom, we did things like, well, what was our greatest sum? What was our least sum? We started doing statistics. So our range was between 13 and our range of sums were between 14 and 34. We looked at, well, how can we figure out the most frequency occurring score? Or what's the median or the middle score? What is the average? Well, when it's all disorganized like this, it's hard to do that. So what the kids did is they ranked the samples, starting with their smallest sum, the next biggest sum, next biggest. And so now, well, our range was 14 to 34. Our spread was 20. Here I have 2 18s, but here I have 6 22s. But my most frequently occurring score was 25 because it occurred 25 times. And it's easy to see that because it's the longest string of answers. The median, the middlemost score, well, it's going to be somewhere in here. And we just keep going top, bottom, blah, blah, blah. And our 2 median scores were 24 and 25, which means that 24 and a half or 24 and 5/10 is our median score. And then finally, the meanest thing I could make them do was to add up all the scores and divide by the number of scores. So they added them up. It was 1,217 divided by the 50 samples, and their average or their mean was 24 and 37 hundredths. And I like using that kind of terminology, 24 and 37 hundredths, or 12 and a half, or 25 and a half, as opposed to 24.5 or 24.37, because it gives more context as to what that number actually means. So the complete rules for that are in your handout. I'd like you to take just a couple seconds right now, and I'd like for you to just practice out loud to yourself. Don't worry about having your mic on. Just outside of yourself, add those up. And while you're doing that, I'm going to show you one more strategy that the kids used to help them with multi-add-end addition. And then I'll show you an extension to that.
And John has asked if you are willing to, you can show your camera, show your happy face, and we will be looking for some participants in a minute.
All I know is Danielle's already earned a prize. And so is Kate. There we go. Now we got some action. Thank you guys. Appreciate you doing that. We have a few people there. Give me a wave in the screen if you want to give me a quick read and tell me how you're adding your dice. When I say a wave in the screen, just go like that. Okay, Danielle, could you unmute and just add yours out loud for us, please?
I was just trying to find 10s. So I did 6 and 4s, 10. And then I had,
I know it's tough when you're on.
I know, I had 2 4s and a 2 that was another 10. And then I was left with 2 2s. So I had 24.
Fantastic. And I'm going to ask you a tougher question. Without reshaking, could you add those dice up differently? Don't feel you have to do that, but that's where I'd go with the kids on that, because what happens is I want them to have multi-strategies. Give me a quick wave, Danielle, if you want to try that one more time, but with a different strategy. I heard no. Okay, not to worry. So when we look at the paper, they have recording here like we did with those 50, but more importantly is that I would actually have them in the book. Let me pull this up here. That is page, excuse me, page 30. Okay. Not to worry. I would just ask them to try to do it several times. So that's 7-up, add up. If the kids don't have a math shaker, no problem. My kids might be really struggling. And so I might say, boom, can you add up those 3 dice? Well, yeah, 2 and 2 is 4 plus 5 is 9. Kids, if I see your dice together on the table, I'm going to see them in parentheses when you write your math sentence. So we're also working on that order of operations. As they get better, I might have them roll 4 dice. Roll it, trap it, take a peek. Well, I have 6 and 5 is 11. 11 plus 2 is a big number, is 13. Again, 6 plus 5 is 11, plus 1 plus 1 is 2, 11 plus 2. And in fact, that's exactly how some kids did their work. They looked and they said, well, I did 5 and 6 to give me 11. I did 3 and 6 to give me 9. That 9 and 11 gives me 20. 2 and 3 is 5. That 5 and 4 makes 9, 20 and plus 9. And so again, it kind of melds right through with what the kids are doing in their brain. Some kids always go 2, 2, and 2. Other kids, like this one, was doing it a little bit differently. They said, well, I have 5 and 3. That equals 6. Oh, sorry, 5 plus 1, that equals 6. And then that 6 plus that 3 equals 9. And then this 5 plus 1 also equals 6. And this 4 plus 2 also equals 6. And those two 6's equal 12. 9 plus 12 equals 21. So it doesn't always necessarily go right next to each other. So I like dice because you can move them around as you're trying different right answers. And so that's kind of our first one there. And that's a quick and easy one. If you have math shakers, that's great. I'm always of the firm opinion that if you can get the kids moving for about 10 or 15 seconds, like we do with that math shake break, that works great. After that, Okay, new round. Take. Add them up. Well, I have 5 and 5 is 10. 4 and 1 is 5. That's 15. 15 plus 8 is a big number, is 23. 24, 25. So, or actually, this. Oh, you know, if I do this over, Mr. Melling, I'd go 2 and 4 and 4 is 8 plus 2 is 10, and then I'd go plus 10 is 20 plus that is 5. So there's an example of kids doing it twice. If you really wanted to stretch them, how many 2-digit numbers can you and your partner add? So now I have 3 10s for 30, 3 1s for 3. I have 33, 41, 13, 35, 65, 31, 14. So how many of these can I add? Well, you know what, Mr. Felling? I have 35 and I have 65. I like that because 5 and 5 makes 10. So that 10's go. Oh, you know what? 35 and 65 equals 100. So that was easy. I might look at something else. Let me just take a peek here. I have 33 and 41. That's another 74. 74 plus 100 is 174. 174 plus 13, that's 74, 77, 87. That's 187. Holy cow, John, you just added 5 double-digit numbers in your head. Yeah, but I had help from my friend Wally. Okay, well, that's good. And so rather than having a kid do it by themselves, I actually prefer having 2 kids working together to see how they can add it. And again, emphasizing the fact when you have a lot of things to add, don't worry about adding them from top to bottom. No one says you have to. Nobody in the real world does. In the real world, people add what's easier and they keep building on. And so if you have 2 shakers, I'm going to give you about a minute. And I want you to just try that right now and just see how easy or how hard it is for you. Again, my expectation is not that you have to add all 7. My expectation is how many can you add? Because some shakes are easier than other shakes. And that's the emphasis I have with kids. And I'm going to continue to be quiet so you guys can think. Couple more seconds. And just pause for a second. So that 7-Up Add Up is also in the primary book for shakers. It is page 45 and 47. So I'm just going to pop to those because that is where I really wanted to show you something here. But this sheet in particular is what I want to show you. So you have your numbers, but you have several, you're going to add it several different times. And what was the strategy that you used? And so if you have this book floating around, the K-3 book, that's where this recording sheet's from. Whereas this recording sheet is from your grade 4, 5, 6, 7 book, and it deals most with statistics. So I know that your schools probably have both of those hanging around. All right. Let's go to sum it up. Now, to sum it up is from All Hands on Deck, and it is a multi-digit adding game, and it uses cards. And the next hardest game is called What's the Difference? And What's the Difference is just right after that. It's on page like 111. And so I'm going to do What's the Difference because that's a lot like the video that we played. And I need a volunteer who would like to play against me. And this is for a prize for sure. Danielle has already earned a prize. If you want to play against me, give me a quick wave in the screen or unmute and say, I will, even if I can't see you. 5 seconds to unmute.
There's prizes.
There's who?
Prizes.
There are prizes.
Does anyone want to join? You can just unmute yourself or say your name in the chat too.
Okay, well, here's what's going to happen. What's going to happen is it's going to be me versus you guys. And I'm just going to peek into the chat for a second here. Fantastic.
I don't
And
think anyone. Yeah.
with the chat, I want you guys to type in some things. So there's some terminology. When we talk about subtraction, because we're going to use what's the difference. There's the minus sign. The terminology is minuend, subtrahend. Sub means below. I actually had to look this term up about 11 years ago because I didn't know. And I've never seen, in 44 years of teaching, I've never seen the word minuend on a standardized test anywhere in North America. But could be the first year, who knows? So we have the minuend. We have the subtrahend. And then, of course, the difference. And I'm going to do this really quick.
Oh, we may have lost John. Just hold on a moment. You can look through your booklets if you have them, and I'll just make sure that he knows that he's been lost. Hi, John. If you're there, it looks like you're here still. Your screen is white. I don't know if it's technical difficulties. Can't. It says you're still in this meeting, but we just can't see you. Oh, I just talked to Jessie. She said that Jane, it was the same thing. She thinks their Wi-Fi may have gone out. Maybe we'll just wait a few more minutes. There's some really great activities, and if you want to explore them, maybe think about how you can incorporate them in your own teaching. I would try to lead you in this. I am actually a big advocate of box cards. I've been using it with my own students before I became a social studies consultant. So I know there's some really awesome activities. So if you want to, if you didn't get a chance, this was emailed to you with the presentation link, so you can open it and see if there's any games that you could play maybe tomorrow. And hopefully John will reappear. There we go. I just readmitted him. Let's see, did that work?
We've been our internet is clonked out twice today, and unfortunately, if it happens again, I'm going to try to do it through my phone instead.
Okay.
Did we get everybody to as far where we had minuend, subtrahend, and we were going to get started, me versus the rest of you guys, and we're going to go through the chat is the way that we're going to have you guys respond. And with the way the game goes like this,
Oh no, John, you're frozen. John, I'm not sure if you can hear us, but
have 11s, wild cards.
you're just cutting out.
Got it. So I think what I'm going to do is I'm going to talk slower and see if that resolves it. Are you give me a thumbs up if you're hearing me?
That sounds better. It's less glitchy.
So very quickly, if for some reason I don't, go like this or like this in the screen, because I may still see you. All right. All right. So I want to get rid of these cards, and I only want to keep these cards. If I accidentally deal a card that does not make sense for the game, then I pretend it was never dealt and I just do it again. And so what happens is I'm going to deal out 5 cards, 6 cards. Can't use it. Can't use it. I can use that. I can use that. And I can use that. And what I'm going to do
Sorry, John. I think you're frozen again. Internet.
is I'm going to set up a subtraction problem. There we go. So Jen, how are we?
You're glitching a little bit, so we missed a little bit of the instruction. The last thing we heard is that you were just set up a subtraction problem.
So what I've done is I've switched over to, I'm now running the internet via my phone via a hotspot. So I think we have less problems now. So long story short, we want to set up a subtraction problem so that when we take the minuend subtracting the subtrahend, we get a difference as close to 0 as possible. Cannot be a negative difference. In other words, you can't have 1 minus 10,000. All right, so looking at all this, I might go like this. Well, 500 something minus 500 something, I'm already only going to have maybe a 2-digit number. And I could have like 61 minus 10. And that gives me a difference of 51. Or I could have 16 minus 10. That gives me a difference of 6. I think that's going to be my best. So this team has a difference of 6 because 516 minus 510 gives us a difference of 6. And so then this group also does their same thing. 1, 2, 3, 4, 5, 6. And they might look at, they're not as lucky with theirs because they don't have any repeating numbers. And so I think what I want is I want 98 here. And I think I want 23 here. And I want 500 and 400. So when I look at this, I don't have enough ones, so I'm going to decompose. And when I decompose, I now have 13 ones, 8 tens, or sorry, 8 ones. 13 minus 8 gives me a final answer of 13 minus 8 is give me an answer of 5. Sorry, I had a little bit of brain. I no longer have, I decomposed that 1. So now I have 1 10, I have to take away 9 10s, so I'm going to have to decompose again. So 11 10s take away 9 10s gives me 2 10s. And because I had to decompose here, I had 4 hundreds minus 4 hundreds. So my difference here is that. And if I understand all that red solo cup work, where we're decomposing and decomposing, it helps kids do something like this as opposed to typically what they'll do is they'll go like this. Well, I think I want to go like 900 minus 800 because that's only one. And then I might go like 410, and I'm going to go like this. And then what happens is, oh, well, I have 111 is my difference. Well, what if you went like this? Oh, well, in this case, I have 109 is my difference. Sorry, yeah, 109 is my difference. Oh, well, what if you went like, and then they start moving all the cards around. So now that you know that that's how we're going to play, what we're going to do is it's going to be me versus you guys. And I'm going to mix up the cards again, and I'm going to deal out 6 cards face up. And then I'm going to give you guys a choice as to which cards you want to use. And I'm going to risk and put this into chat. Hopefully, Jess or Jen, am I still good?
Yes,
Okay,
you're
I
great.
see a thumbs up. That's good. All right. So 1, 2, 2, 3, 4, 5, 6. Well, still can't use that. 6. 1, 2, 3, 4, 5, 6. Get rid of that. 6. Okay, so now my question is this. Do you guys want the pile of cards that I have 1 finger on, or do you want the pile of cards that I have 2 fingers on? Because you guys are going to versus me. So vote in the chat, 1 or 2, and that's the pile of cards. Whichever votes the most, I'm going to give you 10 seconds to vote. 9, 8, 7, 6, 5, 4, 3, 2, 1. We already have 2 people saying 1. So that is your guys' cards. These are my cards. Start working with your cards. It looks like it's unanimous. This may not end well for me. Okay. Oh gosh, I think I'm going to do this. I'm going to go and I'm going to go 400, 300. I'm going to go 1 and 2, and I'm going to go 6. No, that's not going to work. I'm going to go like this. I think I'm going to go like this. I think that's what I'm going to do with mine. And so now that I've worked this out, I have 421 minus 386. So here's another strategy, kids. How far away is this from 100? Well, it's 14 away from 100. How far is this away from 100? It's 21. What's 14 plus 21? Well, that one's easy, Miss Spelling. 14 plus 21 is a big number. 14 plus 21 is 35. So my difference is 35. 11 minus 6 is 5. 11 minus 8 is 3. 3 minus, yep. So my difference is 35. Type in the chat sorry, I'm going to let you guys see the cards now. And I'll give you a couple minutes to figure this out. And then once you figured out what subtraction problem you're going to have, I want you to type it into the chat. So for example, I would go like this. Janie, can you bring me your phone? I'm going to try to fix it up for you. Sorry. Okay, type in the chat. We've got, wow, 51 minus 31 equals 20. But what'd you do? Oh, sorry. You have to use 100 times one number minus 100 times one number. If I only dealt you 4 cards, then it'd be two different digit cards. What you did by going 51 minus 31 equals 20, that's actually a much harder problem. I have one person at 130 minus 125, which equals 5. 15 minus 13 equals 2. Yeah, fantastic. Franca, wow, brilliant. Some kids don't realize that you can have 0 in the hundreds number. Wow, And that's why I like playing this game a lot, because kids are going to say, well, I didn't know we could put 0 in the hundreds. Never said you couldn't. So what I think I see is I see this. So that gives us a difference of 2. Somebody else had something like this, 130 minus 125. So both of them, regardless, you guys have both beat me. So that's excellent. And that kids versus teacher is a great game. Could you do me a favor? Could you make sure that Franca gets a prize, please, Jennifer? Thank you. So right now we have Jennifer getting a prize. No, we don't. We have Danielle getting a prize. Jennifer's just tolerating me. Okay. Thumbs up. Do you like the game? What's the difference? And what I usually do is I usually start the kids off playing to sum it up, which is the addition game. And it's played basically the exact same way. Good full rules there. That game is in all hands on deck on page 107. And what student work looks like for what's the difference is right here. And these are grade 3s out of where are they? I'm going to say, oh, Burbank, California. And what I did is I had the grade 5s work on to sum it up. And then a few periods later in those model lessons, I had them do what's the difference. So this is what sum it up looks like. Each kid's dealt out 6 cards. They came up with their sums. This child had 1,667. This child had 447. This child had, and when you look at it, you're going, well, why did they do it that way? That doesn't give it the best answer possible. I'll explain why in a couple seconds. But what they did was correct. These kids did what's the difference? Again, they had 117, 122. And here, you had some kids that busted. And they busted because the version we were playing was the blind version. And the blind version went like this. You would still play what's the difference, but you blind version is you flip over a card and you must tell us where it's going to go. So I flip over a 5. Do I want it in the hundreds, 10s, and 1s of the minuend, or the 110s and 1s? So I think I'm going to do is I'm going to put it in the hundreds of the minuend. So I flip over my next card. I think I'm going to put that in the 10s of the minuend. I have a 4. I'm going to put that in the hundreds of the subtrahend. And when you're playing the blind version, not only you want the smallest difference, but your difference has to be 0 or greater. In other words, you can't have like 111 minus 999. So the next card is a 7. Ooh, I might want to put it here because then for sure I'm going to get rid of my hundreds. I might put it here. I think I'm going to put it there. And I'm going to put this here. And I'm hoping for a really low card. It's a 9. Okay. So I have 529 minus 487. And so my difference is 9 minus 7 is 2. I have 12 10s minus 8 10s equals 4 10s. And so my answer is 42. And then the other kids do their blind version. So whoever has the least amount wins. For a bonus point, rearrange your cards to see if you can come up with the smallest answer possible. And I think I'm going to do this. Nope, I have to do that, I think. Yeah. So the smallest answer I could have gotten would have been 527 minus 498, and that would have given me a difference of 29. And so lots of different variations. My advice to you guys is this. Anytime you play a game, feel free to change or modify the rules to make it easier or harder. If you have kids that are really struggling, they might only deal out 4 cards. $92 minus 87, boom, as an example. If they're really struggling, you might only deal out 3 cards. If they're a little bit better at it, they might deal out 4 cards. I think I'm going to go like this. Hmm, 278 minus 99. Oh, and start to go like that, so that the more cards, the harder it is. So that is what's the difference, and to sum it up. Give me a quick thumbs up in the screen, or a thumbs up or a yes in the chat if that makes sense, and if that's a game you feel confident that you could teach this week if you had to. Yes, you can. Thumbs up. No, if you can't. Thumbs down. Okay, good. That's what I'm hoping to see. Okay, let's switch gears again. How am I doing for time? Actually, I'm doing well for time. Thanks, you guys. I'm going to go like this. I'm going to switch back to multiplication for a second. And when I look at multiplication, kids in grade 4, 5, and 6, if I take grade 6 as an example, a lot of them, I would say at least half, probably don't know their multiplication facts fluently enough. Is that a fair comment? Shake your head yes, or put a thumbs up in the screen or something to give me some feedback with regards to whether that makes sense to you. Because that's certainly my experience across North America when I asked that question. Well, just out of curiosity, I want you to type in the chat, out of the 100 multiplication facts for up to 10, from 1 times 1 to 10 times 10, how many of those facts do you think the kids don't know? Out of those 100 multiplication facts, how many of those facts in grade 6 do you think they don't know? Type a number into your screen really quick. Half of them, okay? So about 50 of them. 50 of them, okay? Half, okay, fair enough. All right, about 5. Okay, that's interesting too, 24-ish. Okay, so we got a range anywhere from 5 that they don't know to 50 that they don't know. So let's take a look at a couple things here. Let's take a look. Kids coming out of grade 1 have to be able to count by 1. 1, 2, 3, 4. So if you have 1, 1, how much do you have? Well, you have 1, Mr. Fine. And if you have just 1, 2, what do you have? Well, I have 2. And if you have only 1, 3, what do you have? Well, I have 3. So grade 1s, don't tell your principal, but go tell your parents you're doing multiplication. You already know your 1 times tables. Grade 1s, we're counting out the doubles. Okay, 1 and 1, 2, 2 and 2, 4, 3 and 3, 6, 4 and 4, 8. Kids that come out of grade 1 successfully, they have to know their doubles because it's a grade 1 curriculum standard. Well, if they know their doubles, that's the same as knowing, well, if I have 2 2s, that's 4. If I have 3 3s, that's 9. If I have 4 4s, that's 16. So if I have 1 2, that's 2. If I have 2 2s, that's 4. If I have 3 2s, I have 6. These are all your doubles right here. And so they know their 1 times tables and their 2 times tables. They also know their 1 times tables, they know their 2 times tables. So right away, we've cut down a lot of what they don't know. Would it be fair to say, grade 1s, that when you have the number 72, you have 7 10s for 70, 2 1s for 2. And when you have the number 36, you have 3 10s for 30, 6 10s, 6 1s for 6, that's 36. So when you have 3 10s for 30, or if you have 9 10s for 90, you actually know the multiplication for the 10s. So coming out of grade 1, the kids already know 30% of their multiplication table, because they know their 1s, their 2s, and their 10s. 5s are the next easiest for them to know. It's pretty quick. I would say it's pretty rare for a grade 5 or grade 4 to not know their 5 times table. So there's another, now they're at 40%. The next thing that we should see is this. If I have 3 groups of 6, that makes 18. Looking for my shakers really quick here. If I have 1 group of 3 equals 3, 3 groups of 1 also equals 3. If I have 2 groups of 4 equals 8, 4 groups of 2 also equals 8. We call that the commutative property of multiplication as we switch back and forth. And so why is that important? Well, because if they know So example, 2 times 8 equals 16. Well, then they also can figure out very quickly that 8 times 2 is also 16. So now, if they know one fact, they know the other fact. So that's 50% right there. So we're up at 80% that the kids already know. And so the next really, really important one I'm going to have them do is their square facts. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4. I want them to have that square fact because if they have those square facts, they have lots of knowns. They have their 1 times tables, 2 times tables, 5 times tables, 10 times tables. Their square facts, they know the other half. And so when we start to analyze that, get your cameras ready to take a picture. The pink math facts are the ones they don't know. Those 15 math facts are the ones kids struggle with. And so I'm just going to focus on those 15. They already know their 1s and 2s. Why am I going to waste time quizzing them on that? And so I'm going to have them work on that. And so if they have lots of known facts, like all these yellow and green ones, those are known facts. And so can the kid count on her back? Trevor, what's 6 times 9? I don't know. Well, what's 6 times 8? 48. Okay, 48. Oh, it's 54 because it's one more. And so where does that come from? I had Trevor working on skip counting, and Trevor, that's grade 6 in Fort Worth, didn't know it. So we got up and we just started moving our rear ends back and forth. We went 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, 66, 72, yee-haw. Then we're done. Let's start at 60, 36 and go up. 36, 42, 48, 54, 60, 66, 70. Yeah, well, let's go 48 and go backwards. 48, 42, just forward and backwards 1 minute a day. So that when I ask Trevor, what's 6 times 8? He goes like, or 6 times 9. A month later, I said, first of all, I see him in the hall. Oh, Trevor, remember? Yeah. What's 6 times 9? I don't know. I said, well, it's 6 times 8. He goes like this, 54. Because he was going through that skip counting pattern. He was going from a known fact, which for him was 48, and just skip counting up. So if 8 times 6, then, oh yeah, it's 54. And so what we want kids to do is have as many known facts as possible and go from one of those known facts, either skip counting up or skip counting back to get the unknown fact. That's a strategy. So it's a lot less disheartening for kids. It's a lot less disheartening for staff if we have kids realize that there's not that many multiplication things we don't know. So we're going to go to Factor Feud. Factor Feud is on page, I think. Factor Feud is, or Fact Feud is basically from All Hands on Deck on page 42 on All Hands on Deck. And it basically goes like this. So when I look at this, the 6s and the 7s, I think I'm just going to go with the 7s. So I'm going to put the 7 down there. I'm just going to find it. And I'm going to take half the cards, and my partner's going to take half the cards. And we're just going to start working on Factor Feud. And it goes like this. Player 1, can't use it. Player 1 has 10. So 7 times 10 gives me a product of 70. 7 groups of 10 gives me a product of 70. Player 2 has 7 groups of 12, gives a product of 84. 84 is a greater product than 70. That player wins. 12, 10. Oh, wow. 70 is the product for 7 times 10. 84 is the product for 12 times 7. Again, 84 is a greater product, and so on and so on. And if they do something like this, holy cow, we have 7 times 11, 7 times 11, that's 77. Six groups of 7 is 42. 8 groups of 7 is not 42. 49, 56, 56. So I knew that 7 times 7 is 49, and I just went 49, 56, because I knew that skip counting. 56 is a greater product than 42. I win these. I win these. And I win these. And so rather than worrying about all the math facts, focus on the ones they don't know. Kids that are struggling, I might only use cards 1 to 5. Then I might use cards 1 to 6. Kids that are really good at it, they're going to use cards 6 to 12. So you can differentiate it very quickly by which cards you use. Another game we play is Slam Dunk 72 and Slam Dunk 36. Take your tray out, go like this, spill your dice, move your dice off to the side. You, in this case, have a black team and a red team. I'm using Calgary Flames colors today. Okay, and what I have is I have the racetrack and I have the barn. If you win, your dice go in the racetrack. If you lose, your dice go in the barn. So it's red team versus black team. Roll it, trap it, take a peek. 6 groups of 5 is 30. 6 groups of 1 is 6. 30 is a greater product. It goes in the racetrack. 6 goes in the barn. I win. No, you have to say the math talk. This is your one and only warning. If you don't say the math talk, I automatically win the game the next time. 4 groups of 5 is 20. 3 groups of 5 is 15. 20 is a greater product than 15. I win. These guys go in the barn. Thumbs up or yes if you understand how we're playing Slam Dunk 36. If you tie, both go into the racetrack. 6 groups of 6 is 36. 2 groups of 6 is not 36, it's 12. 36 is a greater product. We want them using words like products, factors, add-ins, dividends, minuends, quotients, all those things, because that's the kind of language they're going to see on the Virtual Achievement Test. That's the kind of they're going to see that they're expected to do. And I'm just going to keep going. 3 times 4, 6 times 4. 24 is a greater product than 12. Racetrack barn. And we keep going. 4 groups of 5, 5 groups of 5. 25 is a greater product than that. They win. They lose. These guys have 5 groups of 6 for 30. These guys just accidentally have 4 groups of 4 for 16. 30 is a greater product than 16. We just go down, up the backstretch, and we keep weaving until we go at the end of all the rolls, when there's no dice left, then whoever has the most dice in the tray at the end wins the game. That's Slam Dunk 36. At the front of your handout, that's in Math Fundamental. You have multiplication board. Sometimes what I'll have the kids do before they play any games at all is I want them to get used to how to use the multiplication board. So roll it, thumb. I have 3 groups of 6 for 18. I want them to be able to find the answer accurately. And 6 groups of 3 is also 18. I have 2 groups of 2. That's a square fact. That's 4. And they're going to put down Cheerios or whatever to mark it. 4 groups of 6 is 24. 6 groups of 4 is also 24. And they keep going. And it just helps them to really pay attention to where the answer is. Why? Because another strategy we've been using for not quite a year now. We were reading some, I was reading some research, and I was talking about how the brain does not give up on a problem once it poses a problem that it's interested in. And the analogy I'll use is this: you're walking on the street, you see this guy, and you go, "Oh, I know that guy's name. I went to school with him, grade 2." And 20 minutes later, all of a sudden, "Oh yeah, it's Billy Bomberito." Even though I gave up 20 minutes ago on who that guy is, once the brain has posed a problem, it doesn't give up. It'll continue to work in the background until it comes up with an answer. May not be the right answer, but it's going to come up with an answer that it's satisfied with. You've all experienced that lying awake at night trying to solve a problem. Well, that's your brain not giving up. Okay. And so it has some drawbacks too. So we're going to use that. So if I ask a kid, what's 6 times 9? I don't know. Give me an estimate. I said, I don't know. Is it 1 million? No, it's way less than 1 million. Okay, so it's less than 1 million. Is it more than 0? Yeah, it's more than 0. So we have an answer somewhere between 0 and 1 million. Is it less than 1,000? Well, yeah, of course it's less than 1,000. So now we're between 0 and 1,000. Holy cow, you just eliminated 999,000 different possible wrong answers. Is it less than 100? Yes. Is it more than 10? Yes. So less than 70, yes. Is it more than 30? Yes. And so it's somewhere between 40 and 60. Great. True story. I asked this girl this, okay, in grade 4 when we were playing this game. And before they could look up an answer they didn't know, they had to give me an estimate. And I said, well, give me an estimate. She goes, 20. Actually, she said, I didn't know what 6 times 7 is. So I went through that same sequence with her. And so she got it narrowed down that was going to be somewhere between 30 and 50. And I said, well, give me a number between 30 and 50. She goes, 28. Like I said, true story. I go, well, okay. So I let her look it up. When she looked it up, she just, let's know, 6 times 7. Well, it's 40. Oh, right. I said 28 because like 28 is another multiple of 7 kind of thing. So she had a reason why it was there. And so does that mean the next time she's posed the problem 6 times 7, she'll know 42? No, she won't. But it's more likely, shoot, we just lost the internet for Janie again. So it's more likely that they'll say, well, I know it's somewhere in the 40s. I'm going to say like 44. And they look it up. They go, oh yeah, it's actually 42, right? So what happens each time the brain estimates, it gets closer. And so because the brain's so focused on it, it wants to put it into permanent memory. We've had really good success with kids estimating like that. And so that's kind of the third strategy that I would pose on that. So I wanted to talk to you about Slam Dunk 36, and I just have enough time to show you that, I think. Come on, there we go. Not Slam Dunk 36, but Slam Dunk 72. Slam Dunk 72 has a pattern to it. You're going to take a die and you're going to add another die to it, and you're going to multiply it by the third die. Okay? And this group is going to take a die and they're going to add it to another die, and they're going to multiply it by the third die. Kids, if I see your dice together on the table, I want to see them in parentheses. And so the team who is black rolls their dice, perhaps it takes a peek. Whoops, too many dice. So see now, 2 plus 3 is 5, times 1 is 5. Could go 3 plus 1 is 4, times 2 is 8. Could go 1 plus 2 is 3, times 3 is 9. Oh, I like that. And then the red team goes. Well, I could go 6 plus 4 is 10, times 6 is 60. I could go 6 plus 6 is 12, times 4 is 48. I think I like the 6 plus 4 times 10. So we're going to go 6 times 6 plus 4, and that equals 60. The equal sign just says that whatever value you have on this side, the value on this side has to equal. And so the answer doesn't always have to be on the right side. The answer sometimes could be on the left side. So the other thing is even though we're working on our multiplication skills up to products of 72, we're also working on mixed operations over our operations. We're also working on what the equal sign works with. And so the same thing, winner goes in the racetrack, loser goes in the barn, but often I just have them go like this. And the way you keep track is just circle whoever answers like that. So these guys kind of go through again. Well, that's pretty tough. They're going to go 3 plus 3 is 6, times 3 is a big number. So they're going to go 3 plus 3 is 6, times 3, that equals 18. And these guys are going to roll, trap it, take a peek. Oh, they have 1 plus 2 is 3, times 2 is, wow, they didn't have bad luck. They'd have no luck. Times 2, that equals 6. And 18 is a greater product than 6, they win. Thumbs up and a yes in the screen if you understand how to play Slam Dunk 72. I'm going to be quiet now for 0 time because you guys are now done. This is 5 o'clock and I want to be respectful of your time. So I'm going to mention just one thing with regards to, 2 things actually, with regards to your workshop. One, we're going to do some co-taught classes. So I'm going to be zooming into many classes on October 7th. And if you want your class to be one of those classes that I teach, sign up. Is that correct there, Jen?
Yes, I put the link in the chat. I know Jesse's been advertising it as well. I'm going to, it should be in the chat, but I'll throw it in one more time just in case you joined late.
And the second thing I want to mention is on the front of your handout. On the front of your handout, probably the most important link of all of them is our YouTube channel, Boxcars Education. When you click on that link, when it's open in a computer, it takes you to our Boxcars Education YouTube channel. We have over 150 videos up there. Over 120 of them deal with the kindergarten to grade 6 math curriculum. Slam Dunk 36 and Slam Dunk 72 are up there, as well as what's the difference. There's a lot of games up, a lot of the shaker games are up there. So if you're looking for ideas, boom, go up there and it's easy for you to check that out. Jen, thank you so much for hosting for us. I'm apologizing for those internet glitches. We actually have texts coming in from Rogers to figure out what the problem is, because we've already had them remotely start us twice today.
No worries. That was amazing, John. So many fun games. I know that there are so many activities that teachers hopefully will be doing tomorrow with their students. I wanted to give a little reminder from Jessie that you should have boxcar sets, class sets. Larger schools have multiple sets, and that really the paired math. So you have class sets, but you can just use half of it, and don't
you got
just
shakers, you got cards, you got trays.
Exactly. Jessie wanted to make sure that you find those. And if you haven't been able to find those, please contact her and she'll maybe help you locate them within your school. But everyone should have been set. So
Great.
thank
Thanks a
you.
lot. Bye now.
Bye. Thanks, everyone.
Well, and you got prizes for my participants that helped out.
Yes, I already texted Jessie. So thank you, Danielle and Franca. You will be receiving something in the own email system.
And my apologies to people who volunteered and I didn't get to. Take care now.
My internet didn't work
Okay, so
75% of the time.
so
So